Hi everyone, we are going to be investigating exponential functions. So we're going to use Desmos to help us with this. So if you want to just adjust your window so that the x-axis is between -5 and 5, and the y-axis is between -5 and 20. Okay, so we're going to be looking at functions today in the form of y equals a times b to the exponent x, where a is greater than 1. Okay, so for this first example here, we have y is equal to 3 times 2 to the exponent x. So if we go to Desmos, I'm not going to open up Desmos and flip back and forth, but you can go ahead and open up Desmos and type in y equals 3 bracket 2 to the exponent x. Okay, so when you do this, you should see that the y-intercept is at 0 and 3. So at 0, 3 is our y-intercept. So our function should look something like this, okay? So we have an increasing function. Our domain is x such that x is an element of the real numbers. The range is y such that y is greater than 0 and y is an element of the real numbers. Our a value is 3, our b is 2. So we could fill in this table here to figure out our values, our output of y. So 2 to the exponent -1, and then times that by 3, you get 1.5. 2 to the exponent 0 is 1 times 3 is 3. 2 to the exponent 1 is 2 times 3, so that's 6. If we plug in the 2 for the x, we get a value of output 12, 24, and then 48. Okay, so next what we can do is we can find the change in the y value. So in other words, 3 minus 1.5, which is 0.5. I'm gonna just move this over. I'm running out of space. I'm writing too big. 6 minus 3 is equal to 3. Actually, let me change that. All right, let's try this again. So 3 minus 1.5 is equal to 1.5. 6 minus 3 is equal to 3. 12 minus 6 is equal to 6. 24 minus 12 is equal to 12. And then 48 minus 24 is equal to 24. Okay, so I can see that it's not linear. Okay, next we're going to look at the ratio. So 3 divided by 1.5, 6 divided by 3, and so on. So we're going to get 2, 6 divided by 3 is 2. So we always go back to the ratio 3 divided by 5, 6 divided by 3, 12 divided by 6. Back to the y value, 2. So 24 divided by 12 is 2. And then 48 divided by 24 is also 2. So the ratio is the same as the b value, the part inside the bracket. Okay? All right, so similar question, we've just switched the a and the b. So the y-intercept this time, if you plug this in on Desmos, you should notice that it's 2. We approach the x-axis, but we never actually touch the x-axis. Remember, this is called an asymptote. So the y-intercept is 2, or if you want to write it as a coordinate 0, 2. A is 2, b is 3. The function is increasing. Our domain is x such that x is an element of the real numbers. Our range is y such that y is greater than 0 and y is an element of the real numbers. For the y values, again, we're just going to substitute in. So -1, so 3 to the exponent -1, and then multiply by 2. We get 2/3. 3 to the exponent 0 times 2, we get 2. 3 to the exponent 1, and then times 2, we get 6. And filling in the rest of the table, 18, 54, 162. Okay, the change in the y value, so 2 minus 2/3 is 4/3. 6 minus 2 is 4. 18 minus 6 is 12. 54 minus 18 is 36. 162 minus 54 is 108. Okay, so the ratio, that is, let's see, 4 divided by 4/3. Whoops. And then we have 12 divided by 4, 36 divided by 12, 108 divided by 36. And we should get 3, 3, 3, 3. I think on my last slide here, I accidentally said go back to the Y column. I meant the change in Y. Okay, so 3, 3, 3, 3, 3, and so that's the 3 in the brackets over there. Okay, for the ratio. All right, let me see here. Let's skip ahead. Okay, let's try this one where we have 1/2 as our B value. So y-intercept, if we plug this into Desmos, actually, you know what? I think we'll just say that's the end of this video. You can go ahead and plug this into Desmos and see what happens, okay?